Hi guys, this is the Innovative Minds Tutor. In this video, we are going to work with exponential equations, grade 10. So we are going to look at different types of exponential equations. Right guys, without wasting time, let's get to today's video. There's a golden principle that we need to understand. A to the power of y is equals to a to the power of x. This golden principle will help us to solve many of our exponential equations in grade 10. Consider this. Before you solve any exponential equation, ensure that your bases are the same from the left-hand side to the right-hand side. So when the bases are the same, what do? We drop the exponent, meaning that y is equals to x. So this golden principle will help you. So let's get to the first equation of today. The first equation, we can see that the bases are not the same. It is our duty to make them the same. First thing, we can change this fraction. When we change half, it's the same as 2 to the power of negative 1. Half, it's the same as 2 to the power of negative 1. This is 3 to the power of 3x plus 1. When you change 32, into exponential form, it will give you 2 to the power of 5, right? So let's work out using the laws of exponents. Negative 1 will multiply everything, will multiply 3x plus 1, right? Negative 1 multiplied by 3x, that's going to be 3x, okay? Negative 1 multiplied by 1, that will be minus 1, equated to 2 to the power of 5. So notice the base are the same now. We follow this principle. What did I say? We drop the exponent. So this will be negative 3x minus 1 equated to 5. So what are we going to do? We need to make x the subject. So transpose negative 1 to the other side. When we take negative 1 to the other side, what do we get? It's the same as 5 plus 1. That will be 6. How many times does 3 goes into 6? We can divide both sides by negative 3. So that makes 3 goes, how many times does 3 goes into 3? It goes once. So we are going to be left with, when we divide by negative 3, we're going to left positive x here. How many times does negative 3 goes to 6? How many times does 3 goes into 6? Goes twice, but since it's negative, it's going to be x is equals to negative 2. So that's how you can work out the first equation. Let's work out the second equation. You can see we are given a fraction. Change it to exponential form using a negative law. So this is the law that applies. So this law, when you're given in a form of fraction, change it to a negative exponent. So what are we going to have here? We are going to change 125. What is 125? 125, it's 5 to the power of 3. So when you change it to a negative exponent, we are going to have 5 to the power of negative 3. Right, you can confirm that using your calculator. It is advisable that you pause the video and reattempt it and check the answer. We learn by doing. Remember guys, we learn by doing. So it is true that x, since the bases are the same, x will be negative 3. Hope you saw how we did with number 2. Let's work out number 3. When we work out number 3, what are we going to do? We can see this is a rational exponent. We call it a rational exponent because it's an exponent whereby a base is unknown. So what we could do here, we can divide both sides by 3. Divide both sides by 3 to make x the subject. So we will then say 96 divided by 3. What are we getting there? We are getting 32. 96 divided by 3, that's 32. So we are left with x to the power of 5 all over 4. Since it's a rational exponent, the numerator becomes a denominator and the denominator becomes a numerator. So in our series of video, we will learn more about this rational exponent. But the rule says that what is the numerator becomes the denominator, and what is the numerator becomes the denominator, and what the denominator becomes the numerator. So in this case, we are going to have 4 over 5. So even here, we're going to have 4 over 5. What we could do is to change 32 into exponential form. Just 2 to the power of 5. So remember that we have 4 to the power of 5 even this side. Similarly, x5 to the power of 4. So that's 4 over 5. Then let's apply the laws of exponents. This and this, they cancel. We are left with 2 to the power of 4. This and this are common, and this are common. They cancel each other. Then we are left with x is equals to 2 to the power of 4. So what is x is equals to 2 to the power of 4? That is 16, guys. So that's the solution in this case. Right. So let's take a look at number 4. Oh, number 4 may seem tedious because of 2002 and 2000 blah blah blah. Don't be afraid of this. First thing, look for a common factor. What is common? You can see that when we spelled 2002, we still have 2000. So what we could do, you can use the splitting method. We can split this using the law of exponents that says when the bases are the same, you add the exponent. But we are using it in a reverse manner because we are given something like this, so we have to split it, right? So this will be 2000, and this will be 3 to the power of 2 minus 3 to the power of 2000, which is equated to 8 multiplied by 3 to the power of x. So let's take out the highest common factor. This is 3 to the power of 2000. Then we are left with 3 to the power of 2. To get to 3 to the power of 2000, we need 1. So this is what we're going to do. 8 multiplied by 3 to the power of x. So let's work out what is inside the bracket. Then to be wise, 3 squared is 9 minus 1. It's going to be 8. Equated to 8 multiplied by 3 to the power of x. Then to make 3 to the power of, to make life easier, we could divide both sides by 8. Divide both sides by 8. Then we could say this and this, they get rid of each other. What are we left with? We are left with 3 to the power of 2000, which is equals to 3 to the power of x. So we could say, we can see that the bases now are the same. What do? We drop the exponent, meaning that x is equals to 2000. Hope you find this video useful. Grade 10, and this will also help you in your term 2 as well as in your final examination. I wish you well, and don't forget to subscribe and like and share. We